Okay, part three, it has a lot to cover. Part three is talking about technology, and technology covers technical details on a number of AWS services. Understand what the what service is. So understand most of the questions in cloud in the practitioner level will be trying to see if you understand a service, if you understand what it does, so its purpose. Know what type of use case applies to that service. What is the billing? Is the service a global service? Is it a regional service, or is it a zone service? I think we came across of there are at least 5 global services and there are 2 global services. I think we can remember that the two zonal services is the EC2 and EBS. There's the zonal service, and then global services are IMI, CloudFront, who can help me out. There are about 4 or 5 of them. There's STS, they're all global, and some other
Route
two. Uh,
50K.
sorry,
I think Route 50K.
Growth, yeah, Route 53. Thank you for that. So once you know those ones as global services, the majority are regional. I say the majority because I think when I did share that on our chat sometime again. The reason I'm going into that separation is I remember I was thinking I'll put that into the slides, but I didn't. But if you know the zonal services, know the global services, the rest are just regional services. We have seen questions that try to see if you understand whether a service is regional or global. So it's important that you have those in mind. Now, the key for technology, one of the key things, EC2 is the favorite of the practitioner level. It's a core foundational service for AWS, and it allows you to deploy virtual machines for any purpose. This is what you can call your own computer in the cloud. That's where everything starts. And you can launch Windows or Linux operating systems. Actually, when companies start migrating to the cloud, this is where the first place they land using EC2 instances, because it replicates what they see, um, they experience at the data centers. And there are 2 things that always come up in this area. You always have what is referred to as the user data and instance metadata. And there's a difference between them. It's always a source of confusion, but I just want to emphasize here that the user data is the one you use to run a script during the initial launch of an EC2 instance. That is when you use user data. Now, instance metadata is always data about something. When you hear about metadata, just always think of data about something. Metadata is data about, like you hear about metadata of S3 objects. That's data about those objects. So metadata, instance metadata here will be data about the instance. So for example, the host name, the events, and the security groups that are attached to that instance. So if you can be able to pick this definition, then metadata refers to data about an instance. And if you hear of object, metadata is data about that object. I think that's the only way I also did pick that out. And you get that. So take note that user data is the one that you always run. It's a script that you can use during the initial launch of an EC2 instance. And metadata is just data about the instance. And here we're talking about host name, events, security groups. I think in some questions you must have noticed them. EC2 instances are deployed in a subnet. They require at least one EBS volume, the root volume. So it uses EBS volumes. Um, Keep some billing points here is EC2 instances are built when they are in a running state. You can build them by the hour or second. Per second is actually for Linux instances. Take note. Times you may see a question of an instance was running for maybe 1 minute, 50 seconds, and then was stopped. How much should be paid? And then, yeah, you pay per second. So you pay for the whole 1 hour, 50 seconds. You don't just, so remember that. Then a dedicated host, EC2 instance is always located on the same physical server. So it's used mostly in cases of bring your own license, right? We have seen questions on Yeah, maybe you are moving an Oracle database with a license, or you for certain reasons, you should be able to know when should you use dedicated host. If you are not comfortable with when to use dedicated host, I'll say look at that. But the key aspect is when you are moving, let's say, servers from on-premises to the cloud, and you are trying to ensure that and you have license that maybe you don't want to let go yet, or for some reasons it's some high security service or software that has to run on its own dedicated host, but it comes with a price. Dedicated hosts are the most expensive, and during our lectures we did cover how that looks like. So in the part of EC2 instances, then it has key purchase options. You have reserve instances. Reserving capacity can save up to 75% compared to running the workload with an on-demand instance. We'll come to on-demand instance. So there are different ways when you are buying reserve instances. You can either pay all upfront. All upfront is always the cheapest. That means you have the highest uh, discount. Partial upfront, reserve instances, you pay part upfront and remaining, it makes sense. So you'll be paying partially and the remaining later. So the discount is not as compared to all upfront. And of course, no upfront, which means, yeah, you don't get a discount as more. So when you see a question that is maybe trying to see which one is the cheapest option, and you see all upfront, yeah, start looking at that and paying attention on the other things. Because, and take note that contracts always run from 1 to 3 years. So if you are going for a reserve instance, if you see a question, make sure that you are very clear that you'll be using at least 1 year. Because if it's less than 1 year, there will be no need to go for a reserve instance. Yeah. Then on demand, pay by the second or half instance per second is for Linux instances. We mentioned that. And yeah, so on demand is the case where, yeah, you are just using the instance, you are paying for it as it's going. If after 1 or 2 months you don't need it, you just stop it. So that's the one that coming to mind. On demand, spot instances allow you to set a bit price for unused EC2 capacity. Take note that it's unused EC2 capacity. So if at some point AWS have instances that are idling around, yeah, there's a possibility to use them, and the price remains below the spot. So you use them as long as the price remains below the spot price and EC2 instance is launched and available for data processing. But the key thing you should know with spot instances is that they can be taken at any time. So you can use spot instances for critical workloads. Workloads, that's very not a good option. So when do you use which option? If you're having an instance that is consistent and always needed, you should consider a reserve instance. If you have batch processing where the processes can start, stop without affecting the job, then think of spot instances. So batch processing jobs, that these are the ones that if the job stops, so if the EC2 instance is taken, that's a spot instance and it comes back, and yeah, the batch processing job can continue. If it's inconsistent and need instances that cannot be stopped without affecting the job, so think of on-demand instances. I think another one that I miss here is you can also use schedule reserve instances when you have when you are certain that you have some workloads that will run at particular days of the week. Say every Monday from 8 o'clock to 12 o'clock, there's a particular job running. You can use schedule reserve instances. If that's happening for more than a year or so, you have a much better price. So I'll just say, if you are not very comfortable with, it's very important to know all of that, those different instances. And I think one thing I left out there was um, convertible reserved instances. But we know that's instance types that if you are planning to change your machine type, or maybe an OS, that's very possible. You can go for convertible instances. Um, I'll leave that. Everyone should just take note of to look into convertible if you are not yet comfortable with the concepts of convertible instances. AMI machine, okay, machine image, I'll fix that. It contains pre-configured operating system. So this is like when I think of AMI, think of it like in the past days, you need to have a CD to put into in the traditional, let's say on your computer and install the operating system. So AMI here is like the CD that you use for EC2 instances. So they come with pre-configured operating systems. And that's why when you want to launch an EC2, you have to go and pick an AMI, a particular one, which operating system, just like if you had in the traditional sense, if you had a laptop or a computer at home, you need a CD to install maybe a Windows operating system or a different one to install Linux. So the AMI here is the one that comes to play the role of installation CD here. Some of them can come with applications installed, just like you have a Windows CD coming with maybe Microsoft Word, Outlook installed. So you have to notice that AMI belongs to a region. So if an AMI is in the Sydney region, it does not necessarily mean that it will be available in Singapore. And they have different IDs. So that's something that you notice. So you can't take an AMI from another region and then think that you use it in a complete different region. Those are just some few things to know about the Amazon machine image. Not really much. You can capture an instance as an EC2 instance can be captured as an Amazon machine image. This is when you may want to create. So this is what you can do. If you have an EC2 running, let's say in Dublin region, you can capture that image, make a snapshot of it, and then send that image, say, to um, US East 2, and then launch an instance that will use that image. So that's a way of moving an AMI from one region to another by creating. So I can decide I made a snapshot of a EC2 instance, say, running in Dublin, and then take that snapshot and then launch an EC2 instance. So that's a way that you can capture an Amazon machine learning. It will run because there you are launching but the snapshot. But remember, it's not the AMI itself that you've moved, but you've carried a snapshot of an EC2 instance. And you can use Amazon AMIs. There are some you can buy from the marketplace. There are some that are community. And yeah, you can take one and customize. So you can take an AMI and let's say you want to have some scripts running on them. Yeah, you can deploy and then from there create your own custom AMI. I don't think many questions come from in this area, but that's something to know at least. EC2 family types. Yeah, we did talk about the different types of EC2. There are details of T2, micro, nano. I don't think there's a heavy demand of this at that level, but it's good to know that there are the general ones are the general purpose, where here you are looking at the web servers, which is used for web servers. You have the compute optimize, which are used for batch processing workloads, media transcoding, or high performance web servers. You have uh, you have memory optimize that process large data sets in memory, and then storage optimize workloads that require high sequential read and write access to very large data sets on local storage. Yeah, it is good to know, but yeah. Um, let's look into storage. Object storage, S3, block storage, EBS, instant store, file storage, EFS. This should be very clear for everyone. If you think of object storage in AWS, it's S3, block storage, EBS, or instant store. And I put instant store there for a reason because we'll need to look into that. Then file storage, EFS. Let's look at object storage. Um, yeah, so S3 object storage and objects here, objects are used to say are saved in what is referred to as buckets. This is a regional service. It provides different storage classes. We'll look into that. It stores data across multiple availability zones, at least three of them. I think if you there's a link that you can join that comes under that you can look into. But it stores data across multiple availability zones, high availability and durability. Availability is clear. Durability is the possibility that the data can be deleted. So it's not durable. That's what durability stands there for. Um, so high durability means, yeah, the risk that your data will be deleted is very, very low. Enable URL access for files. So there's a possibility to access the files. When you always upload a file into S3, it always ends up with the URL. So you can access the file that you've stored with the URL. It provides transfer acceleration for for uploads using AWS edge locations. You can configure roles for data lifecycle. We'll talk about that. Remember that a single object, the maximum size that an object can have on S3 buckets is 5 terabytes. Make sure you take note of that. But the amount of data you can store on Amazon S3 is unlimited. So an object can take a maximum of 5 terabytes, but the number of objects that you can store are unlimited. I noticed this used to confuse some
Mm-hmm.
people. So take note that the maximum size that you can store is 5 terabytes, but the number of those objects that you can store on S3 is unlimited. So that's why S3 is an unlimited storage service. If you are trying to upload data that is more than 100 megabytes, you use what is called multi-path upload. There's a D there. So any upload greater than 100 megabytes uses that. So what are the use cases of S3? Static website hosting. You can host website content. So pictures for websites or files or JavaScript, you can just store them on S3. Video or audio streaming or big data lakes. That's where you use the major use cases for S3. So lifecycle policies will allow you to automate the transition of an object from one storage tier to another. So for example, after 30 days, an object can be moved from the standard storage tier to infrequently accessed tier. And after another 30, will be archived, the data can be archived. So can be moved to say Amazon place here. One concept is also versioning, which is each time you can decide to enable versioning so that if you upload the same data, rather than overwriting that data, like what you always experience in, let's say, when you know, if you have a picture on your computer and you want to store the same picture, you can just overwrite that depending on if you accept, and then the old picture will be lost. So what, but for object versioning, what happens is every object that you upload has its own ID. So even if you upload the same picture twice, and if versioning is enabled, so two of those pictures will be existing in your system, and they'll have different IDs, and you can always trace that uh, using that key. So it's a feature. Don't really think it's the point that is really key is life cycles policies here. Know that for object storage, if you want to move data from different storage classes, you use life cycle policies. And these are the different classes. The standard is used for data that is frequently requested, and it's the default storage class. If you don't specify a storage class, it will automatically go to standard. You have intelligent tiering. It will change an object storage class based on usage patterns. So intelligent tiering is in case you have data that you don't know whether you will be accessing frequently or infrequently, data that you don't know the access patterns, you will just put it in intelligent tiering. Then standard infrequent access, as the name says, is for infrequent access data. If you are sure that the data is not going to be accessed frequently. Then one zone infrequent access is when you don't require very, very high durability here. So I think we have said that this is used when you require secondary backups. So for example, if you have data that can be easily regenerated, a good example is maybe a photographer who has many pictures, but he needs to create thumbnails of those pictures that can be used, let's say, for his website. So he can decide and store these thumbnails on one storage. The reason is if the pictures, because in one zone, just as the name says, is stored only in one zone. It's the only storage class where data is stored in one zone. All the others are stored in three or more zones, availability zones. So if that data, if that one zone, maybe for, let's say, there is something happens and all the data in that one zone is deleted, it's not too bad because he has the original data. He still has the original pictures and he can create uh, different thumbnails. So it's a use case. So you use that for secondary backup data that you know you can still get if something happens to it. Glacier is used for archiving and Glacier Deep Archive for long-term archiving. All of them are used for archiving, but it's just that um, one is used more than other. And I try to bring clarity here. Glacier is designed for archive data, 90-day minimum storage duration before you can change. Data here can be retrieved in either minutes or hours, and this less than 12 hours. You pay for a retrieval fee per gigabyte. It's 5 times cheaper than standard storage. So if you have data that, yeah, you can, you just want to archive, and it's mostly used by in the banking industry, in the healthcare industry, where maybe that records needs to be kept for a long time and maybe not access. But if they need to bring them up, you use you can retrieve them as soon as possible. But if you still have data that can stay much longer and can be, and if you want to access them, you won't bother. Let's say even if you get the data after 12 hours, then it makes sense to store that in S3 deep Glacier, and it requires a 180-day minimum storage duration. Uh, and you also still pay for a retrieval fee per gigabyte. Yeah, the statistics of over 23 times cheaper than that, I don't, it's just not essential, but it's just good to know, but not really crucial. But knowing the difference of S3 Glacier Deep Archive and S3 Glacier, especially the time, the retrieval time here is important um, for the exam. Okay, let's talk block storage. Block storage here, this persistent block storage. When you talk of EBS here, elastic block storage, um, it's persistent, or when you want data to be stored permanently, think of EBS. And I emphasize permanently because we know there is one that is ephemeral or temporary storage. And it enables redundancy within an AZ. So it's a zonal, that's what we said, it's a zonal service as well, redundancy within an AZ. It allows users to take snapshots of its data. It offers encryption of its volumes. You can encrypt the data that is in your, your EBS, and there are different types which we will come across. Um, You can call it the disk drive for EC2. Yeah, I was just trying to make an analogy with what we have in the traditional setting, because we've said EC2 is like your computer in the cloud. So the disk drive will be EBS, and I mentioned that your AMI will be like the CD you put in when you want to install um, install the operating system. Yeah, EBS volumes can be accessed by only one running EC2 instance at a time. So yeah, by default, that's what you can do with an EBS. It's just can be accessed by one EC2 at a time. Then they are stored on separate hardware, and it's always, that's why it's referred to as network attached. Notice here, EBS volumes are stored on separate hardware. So you always call EBS network attached storage. And there's one feature that you can enable, which is if you enable the feature delete on termination, your EBS volume is deleted automatically when the EC2 instance is terminated. So the reason that is there is because when you delete your EC2 instance, it does not always mean that the EBS volumes that you have attached to it are deleted. So it's a very important, something important to know. If you create an EC2 and you create an EBS volume and attach to it, there is cost associated with the EBS. If you delete your EC2 instance, the EBS that was created for it will still be existing, and if you don't delete that, you'll be incurring cost. It's a mistake that some people make at times at the beginning. But to be able to ensure that if you are very certain that you won't need the data again, you can enable a feature called delete on termination, and that will always go. But the key things to get about EBS is that it's used for permanent storage. Uh, you can make snapshots. It's redundant in an AZ. It's a zonal service. It offers encryption, and there are multiple types, which we'll talk here. There's the general purpose SSD, which is cost-effective volume designed for general workloads. So at the practitioner level, they may just want to, I think they always just ask which EBS volume types for general workloads, and it's general purpose, or maybe provision iOS SSD that's high performance volume for low latency applications. So what EBS volume type will you need? Throughput optimized HDD is for frequently accessed data, and core HDD is designed for less frequently accessed workloads. I think there's no shortcut to learn this than to find how you can look at this and try to have an understanding and be able to remember if required. Now, this block storage, instant store, remember that EBS is stored on separate hardware and is then, when you provision it, is kind of coming from the network. But instant store is always installed on the host where the EC2 is running. We did have that in our lecture. I think that should be clear. But the key thing about instant store, based on the revision we've been coming, that I want everyone to take note, is that it's temporary block level storage. At times it's referred to as ephemeral storage. So that is where you have where instant store comes in. It's located in the disks that are physically attached to the host operating system. It's ideal for temporal storage of information that changes frequently, such as buffers, caches, crash data, and other temporary content. So if you see a question and it's talking about temporary storage for cache, and even though it's talking about EC2, we have seen some of them, start thinking of instant store. Take time and read the question again and try to see that instant store will be a fit, because when it's talking about buffers or cache, that has come a couple of times, it's very likely that the right answer will be instant store. Um, yeah, but it will be essential that you review that carefully to see that it suits. Okay, I'll try to go. Let's finish this and then we'll have a short break. I know it's taking long. When I thought I was going to have a break, but everyone was okay. But let's just go ahead. Or I'm watching the chat in case there's anything. Anyone can always let me know. Then the virtual private cloud. Let's talk about that. What's VPC? It's a logically isolated virtual network in the AWS cloud. That should be a definition that everyone should have in mind. It enables you to launch AWS resources into a virtual network that you have defined. It's a regional service, and when you create VPC, it sits across all availability zones within a region. So a VPC, remember, a region is 2 or more availability zones, and each time you create a VPC, it will sit across all those availability zones. Those are very key points for VPC. The CIDR, CIDR, there's always referred to as CIDR. That's the IP address range associated with the VPC. When you always create a VPC, there's always an address range that is given to it. And remember, when you take an address, we have discussed this, what a subnet is, a sub-portion of an IP address. So you can take an IP address and you break it into separate subnets. Maybe, remember, a VPC covers all the availability zones, you may want that each zone should have a particular subnet. So the VPC comes with an IP address range. And since the VPC covers two or more availability zones, you can take that address range and break it into subnets so that, let's say, availability A has a particular range and availability B have a particular range. That's one way you use subnet. It's zonal. You need a subnet within each AZ you wish to deploy resources. You have what is referred to as flow logs. You enable them to capture information about the IP traffic going to and from the network interfaces in your VPC. This is something everyone should be familiar with as well. Security groups. Don't go to the exam if you don't make a difference between security groups and NACL that will be coming. So the first thing is they act as a stateful virtual firewall for your instances to control inbound and outbound traffic. Stateful means traffic that is allowed in is also allowed out. You don't have to bother. So rules, allow rules only. All traffic is implicitly denied by default. So the only thing you configure with security groups is allow. Any other traffic is automatically denied. And rules are not ordered. I added that there because, yeah, make sure you know that when it comes to security groups, rules aren't ordered. Then security groups are attached to the EC2 instances. So they function at the instance level. The three things to remember key, they are stateful, they are only allow rules only, and they are the instance level. Those are some three key concepts, and the other ones that you um, need to know. And stateful here means stateful means it's more of an intelligent than stateless. Stateful means, for example, if you allow traffic to go in, so if you allow traffic to go in, then the return traffic that is associated to maybe the IP address that came in should automatically go out. So it's stateful. So a security group is able to understand that if traffic is coming in, if traffic comes in, and then if it's from a particular source and is going back, then it should also go back without an issue, right? So stateful here, I'm answering the question on clarifying stateful. So stateful comes with the idea of if traffic goes in and and let's say a certain host send a particular data, and then the security group allow that traffic in. So if data is coming back, that is for that data, it should be automatically go through. Now, maybe if I talk about stateless is the situation where, let's say a particular host wants access in, okay, it's allowed in, but to come out, you need another role to clearly specify that it should be given the possibility to go out. So it's not automatic. So stateless means the device that is working in a stateless situation is not intelligent enough to realize that this traffic that came in, that is going out, it belongs to that person who originally asked for it. So stateless here is, it doesn't have that intelligence. So stateful has some sort of, stateful here, it stores the state, So if traffic comes in from a particular host, and then if traffic is going out for that host, and if it was allowed in the beginning, it should be taken in. Great. So I think that's clear. So allow rules only, security groups are answered. What's the difference between VPC and VPS? We'll come to that. VPS is something else, but the definition of VPC is clear there. Maybe we'll look for the definition of VPS later then. So not NSACL is an optional layer of security for your VPC, and it acts as a stateless firewall for controlling traffic in and out of one or more subnets. So stateless here means inbound connections also need an outbound rule. You see the difference? So data inbound connections, even when they're about to go out, they need a rule that would actually say they should go. So you have allow and deny rules. So for network access control is you need allow and deny, and the default here allows all traffic, and you have to create traffic that will explicitly deny traffic. So customer network access control list will deny all traffic by default. And rules are ordered. So if you have a question that comes up and is asking for what are the following, which of the following two blah 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 are true about security groups, and if you see one listen, you see something there that the rules are ordered, just know that it doesn't belong to security groups. You should make sure that it should fall within stateful, only allow rules and attach to an EC2 instance. For NAT access control list, it belongs to it operates at the subnet level, it's stateless, so it has allow and deny rules, and then rules are ordered. Okay, let's look at EC2 auto scaling. It allows you to increase the number of running instances on demand or on a schedule. So auto scaling is always is always used alongside elastic load balancers. We have seen that where traffic is being distributed to different instances, and maybe depending on demand, you may want to have more EC2 instances, and if it happens that demand is falling, you want less. So auto scaling um, can help do that. You can set the maximum and minimum number of instances that you want running. And auto scaling, we've demonstrated that before creating an auto scaling group, you need a launch template which contain the AMI or some basic configurations that will be used to launch new EC2 instances. Because if you are launching new EC2 instances, um, you need to launch an EC2 instance, you always need an AMI, and in some cases, maybe security groups are configured. So you need to create a template so that an auto scaling can use to decide how it should launch new instances. Um, yeah, auto scaling group is a group of EC2 instances that are managed by the auto scaling feature. Okay, let's talk about elastic load balancers. Elastic load balancers distribute traffic to healthy EC2 instances, ensuring traffic is evenly balanced between the instances. And notice it says healthy EC2 instances, because there's a feature that if it realizes that the instances are not healthy, depending on what you've configured to mean by healthy, it won't be used. Um, so there are three types, but two are the ones that I use. One is already no longer in use. The first one is the application load balancer. And what you should remember is that it functions at layer 7. Application load balancer functions at layer 7 of the OC model, and it directs traffic based on the content of the URL. It's also known as path-based routing, and is suited for HTTP and HTTPS traffic. Why? Because we know HTTP and HTTPS are layer 7 protocols. We've seen that during the lecture. So make sure that you are very familiar with the fact that application load balancers are for layer 7. Is for HTTP and HTTPS traffic. So if there's a question and it's not talking about HTTP and HTTPS traffic, and it's talking about the type of load balancer, you should read carefully, and you will see that it's not definitely the application load balancer. And then the other thing is traffic is based on content of the URL, which is known as path-based routing. I think we have seen questions like that as well in the revision. The network load balancer operates at layer 4 of the OC model and is suited for TCP and UDP traffic. And the key thing that it does is it's capable of handling millions of requests per second. That's what you should remember about the network load balancer. There's what is called the classic load balancer. It was for applications that were built within EC2, but it's no longer in use. You may see that in questions, but most of the time, I think it's just a distractor. The ones that you really have to master and know where they function, at which layer, which protocols they support. Application layer 7, HTTP, HTTPS. Network is layer 4, support TCP and UDP traffic. and can handle millions of requests per second. Don't confuse, because I noticed people were confused when they talk about application layer, because when you look at the network layer, network is talking of, when you think of network, you can be thinking of the path, but that's not, that's a function of the application load balancer. When you're thinking of path-based routing, it's not, the path that is handled here is not the one that you would think in the area of networking. Yeah, so make sure you have those distinctions very clear. Now, Amazon CloudWatch, this is a very important service. Um, it's used for monitoring, logging, alerting, and can trigger automation. It collects logs, metrics, and events from most AWS services. And it will track metrics to provide you with data and actionable insights to monitor your applications. I think there's no shortcut for this one. You just need to know what it is and what it's doing. It's mostly, yeah, it's a metric service. The way I always think of it is when you think of Amazon CloudWatch, think of when you think of monitoring. So you think of CloudWatch, you are watching something, you are monitoring, and what are you monitoring? You have you're monitoring. Um, it's the key. You monitoring. There's alerting, there's logging, and there's events. So MALE. So CloudWatch is mail, M is for monitoring, A is for alerting, L is for logging, and is for events. If that can help you capture those key things, yeah. And the other point I highlighted here, it can be used to create automated and scheduled actions. We've come with questions that are trying to see if you understand this, because there are, if you want to create an automated or have an something to come at at a particular time. We had a question that was saying require two services. I don't think many questions will come that need you to handle two or more services, but you may have one or two questions. And yeah, but the key thing I wanted to highlight here is you can use CloudWatch to create automated and scheduled actions. Okay, okay, I think I repeated this, sorry. Okay, relation database service, RDS. Let's look at the Amazon Relational Database Service. Um, a managed relational database product that makes it easy to set up, operate, and scale a relational database in the cloud. It handles provisioning, patching, backup, and recovery of your database and launches to a VPC. So yeah, that's just straight from what we've been talking about, what is the RDS service. And it supports deployment across multiple availability zones, multi-AZ, remember disaster recovery, and high availability. Each time you hear multi-AZ, and then some platforms support read replicas. And when you think of read replicas, this is when you want to increase performance. Make sure that these two features are very clear to you. I think I have, come back to that again. Um, but the key things you should pick from here is with Amazon Relational Database, why will you leave your on-premises database to move to the cloud to use the database there? The key thing is it makes it easy to set up, operate, and scale a relational database in the cloud. And this is far easier to when you are comparing to what you can do on premises. So the patching, backup, and recovery of your database is also not complex there with those two features. And the other point is have a fixed schema and define a relationship between records in tables. That's where the name relational database come from. There is a relationship that is defined by the records that you have. We gave the example of an Excel sheet, and we did in our lectures, and we did highlight. When you need to fill in those separate fields, be it the columns and the rows. Each there should be an entry. So that's what it's mean by it's a fixed schema. You have to define that before you start. provides both general purpose SSD and provision IOPS SSD drive options. So those are the kinds of EBS volumes that you can use for relational database. It uses the general purpose and the provisioned IOPS drives. The different, they could refer to it at times as database engines or platforms. You have the MySQL, MariaDB, SQL Server, Postgres SQL, Oracle, and Amazon Aurora. Those are the six um, Amazon relational database service that are available on AWS. And just for emphasis, I try to bring this here on the multi-AZ for disaster recovery for clarity for maybe anyone who is still not yet clear with this. The point is, remember, it's multi-AZ, so you can have this availability zone 1, availability zone 2. You can have, say, a service here that is accessing the database. So when you configure multi-AZ, what happens is you create a relational database here, which you call here the primary database, and there's a secondary database here. So your services will be actually accessing this database through what's referred to as the CNAME here. So your services are accessing this. And the reason why you've done that is for disaster recovery of high availability, because what happens if something happens to AZ1? If you didn't have AZ2, if AZ1, if something happened on this other zone, that will mean your services won't be able to have access to the database and everything will collapse. So to bring high availability, you introduce a secondary database that exists on a different zone. So that if a disaster was to happen to this one, this is not this case. If this one is no longer there, then it will automatically redirect traffic to this one. And at no time during the existence here, data is only read and written on the primary database. This one is just in standby motion. Nothing is accessing it. So data is only written here and it's only read from here. If something happens, the redirection comes here and data is read from the secondary database. So, and that's what you use now. So yeah, okay, so you'll be using the secondary database. Now, this other one now is the case for read replicas. Read replicas is for performance. And what's happening in this case is data is written to the primary database and is automatically replicated to the read replica. Just to highlight, I didn't indicate here also there should have been an arrow to indicate that data is also there's replication of data to the secondary database here, so that when this falls, then it's taken over. It doesn't mean that because this is not existing on its own. So there's also an arrow that is supposed to move here to show that if something happens to this data, as data is written here, it's immediately written here. As it's written here, it's immediately written here. But nothing, this one have no access. It's just in the case that when this dies, then this will take over. Just like here. So in this case, data is written to the primary database and is immediately also as well copied to what is referred to here as read replicas. And then you are when the function of this service is to read data, it's read but from this instance. It's read from the read replicas. But when the function is to write, it's written but on the primary database. So I remember someone asking read and write. So remember, reading is the example of, let's say you are accessing the website and you just want to read the content of the website, you are just reading. But imagine that they say you have to fill some data. That website has a form and you have to fill data on it. The data will need to be written in the database. Then that's the case where it's written. So these operations are separated, and what happens here is increased performance, because when data is written just and read from the same instance, there's some sort of degradation in performance, and a spread in these two functions helps to improve the performance of the overall system. So when you think of RAID replicas, think of performance. Okay, let's talk about Amazon Aurora. It's just an RDS service that can be configured with MySQL or PostgreSQL database engine. So it's compatible with that. This other key fast, 10 faster than MySQL, 3 times faster than Amazon Aurora. It's distributed. It has a fault tolerant self-healing storage system. Take note of this. It's the only database that has fault tolerant self-healing storage system. You may need this. It's also available as a serverless solution. The key things I would say is it's compatible with MySQL or PostgreSQL. I think we have seen questions that are trying to see if you understand the fact that you can migrate your MySQL database from your traditional on-premises setting to AWS, and you can pick Amazon Aurora as one of the RDS services. So if you had a question that is asking you moving your MySQL database from on-premises and you want to move it to AWS cloud, you can use RDS, um, MySQL that we saw earlier, or you can use Amazon Aurora, because Amazon Aurora is compatible with MySQL, and it's the same thing for PostgreSQL. But you cannot move, say, Oracle from on-premises and you want to put that to Aurora. Aurora is only compatible to MySQL and PostgreSQL. So make sure that distinction is there, and then the fact that it's self-tolerant. There's more here for those who like pictures. That talks more here. I just picked this from our notes, so if you've been reading, you'll definitely see it. If not, you can still look at this after. Then the favorite Dynamodb, everyone's favorite. And we know, we know,
Manol
we know,
Kimi.
we know the person who made this favorite in this group herself is here. So, Lady T, if we leave this here, you go, you handle it. But before we come to that, someone is asking what does self-healing means. Self-healing storage, that means if something was to happen to the storage, Aurora will be able to handle that. So that is what self-healing there means. Self-healing storage. It's just that, yeah, if something happens with the storage, it will handle. But then, um, yeah, so that's for the meaning of self-healing. Then DynamoDB, it supports, did I keep a slide? I didn't. Okay. Okay, I was expecting something else here, but let's see. Okay, no SQL database. So not take very note, good note is a no SQL database, this DynamoDB. What we have been looking before called relational database are at times referred to as SQL databases. And remember I said that they have a fixed schema. Now for no SQL database, they don't have a fixed schema. You know, they are very flexible. So it's a key value and document database that delivers single-digit millisecond performance at any scale. Take note of this, key value and document database that delivers single-digit milliseconds performance at any scale. If you see a question talking about this, and it happens that it's not a relational database, just think of DynamoDB. It supports automated scaling based on configuration. It offers in-memory cache with DynamoDB accelerator. I just added this for those who are curious because if you see something like in-memory cache and they're talking about DynamoDB, then look at Dynamo. Look if the question have DynamoDB accelerator. So if you hear DynamoDB and they're talking about in-memory cache, DynamoDB accelerator or DAX will be that. You query Amazon DynamoDB with API calls. Just an addition, it's a fully managed NoSQL database service. It's highly scalable. It enables extremely low latency at virtually any scale. It's serverless, so you don't provision any systems or you don't maintain or install software, you just use it. It's a it's a very key service, NoSQL service for the practitioner level, and I'll really say make sure you have this on your fingertips, all the key features before you go. Here is a much more better organization of what Amazon DynamoDB is about. Flexible, you see, it's not fixed. It's flexible key value database service for any scale, performance at scale, serverless, comprehensive security. This one here, okay, encrypts all data by default and fully integrates with AWS identity access and management. So global database for global users and apps. So yeah, key points. That's straight from the notes, so I think you should know. Then some other key ones that I will really say, make sure you know them, is the Amazon DynamoDB, which is it's a NoSQL document database. So you have documents in JSON format. And then there's also Amazon Neptune. It's a NoSQL graph database. So when you hear of a graph database, start thinking of Amazon Neptune. It's often used as data storage for any recommended engine behind a retail website. So we had good notes on that. You can check that as well. Then Amazon Elastic Cache allows you to seamlessly set up and run scalar popular open source compatible in-memory data stores in the cloud. It's fully managed. It comes in forms of in two flavors, Redis and Memcache. I would say try to see the difference between what is Redis and Memcache. I can't remember offhand, but I'll say for if you are curious, you can look into that. It's fully managed in memory. It provides low latency, enables scaling and replicas to meet application demand. It handles common use cases, including database layer caching and session storages. So when you are thinking of, we have talked about caching, where is the case where you are storing data maybe temporarily in block storage. But when you are talking about database and handling data in memory and you want to do caching, that's where Elastic Cache comes into play. And this is just an overview. This again comes from our notes. If you've been looking, relational database, RDS, we have all of them here, six. Key value, DynamoDB, so in memory, you hear Amazon Elastic Cache. So you can align all of this. So if you are in an exam and you know what the examples of relational database, key value, document database, sorry, in memory, graph here, Amazon Neptune, search, Amazon Elastic Cache service, time series, Amazon time series, ledger here. I don't think these ones are ready for the practitioner, but it's important to know the first ones here, right? To maybe search, why not? They're not so complicated to remember. Okay. Um, okay, I don't see any question. Any AWS database migration service. This is the one when you want to move your database to the cloud, because migration is a very, very complex complex topic. Let me not say complex topics. It's critical in the fact that most companies will want to ensure that if there's migration, how can it be? How can my customers still have access during that period? And AWS database migration service enables you to securely migrate data for both homogeneous and heterogeneous
Oh,
migrations, either all at once or
sorry.
at the
What happened?
incremental level. So I have a diagram here. What does that do? What does it help? It reduce the database administrative burden. No need to re-architect existing applications. Get better performance. You should really, that's advantages of moving to the cloud. Um, yeah, so that we had that diagram. I don't need to really go down deep into that. That's all about database that I have. And there's one component, cloud formation, that comes up many times. This is used for to automate deployments. And the key thing here is it provides infrastructure as code capabilities for AWS. It's a managed service for provision infrastructure based on templates. So if you are thinking of provisioning infrastructure based on templates, think cloud formation. If you're thinking of infrastructure as code on AWS, think of CloudFormation. It comes with no additional charge, and the templates can be written in what is called YAML or JSON files. I think I'll have an example. So CloudFormation manages the dependencies between the resources and provides strict dictation to find changes in your infrastructure. The key elements are document or code, stack the resultant set of resources that CloudFormation provisions. This is just extra detail for the examination. What's key is CloudFormation is infrastructure as code. It's based on templates and it comes with no additional fee. And you can write the code in YAML or JSON format. And this is an example. I know I didn't show this on the lecture, but this is how a CloudFormation YAML file will look like. So you just write some basic code, right? Create an S3. Here, the description of the code here is create an S3 bucket, and then you call the resource. You type AWS S3 bucket properties, bucket name. I give the bucket name. That's just it. And if you go and deploy this on the CloudFormation, um, on CloudFormation, then an S3 bucket will be created, and you don't need to go and let's say create a bucket and you want to create. This looks, and if you are, and this is the same code written say in JSON format. So you may be wondering, why should you be writing code? The thing is, just like with, imagine organizations, they don't just run one service or two, they run huge amounts of services. And if you are going to be clicking and clicking to create them, as I say, it becomes very, very complex because the next thing is, how do you know what was created and what was not created? What should be deleted and what should not be deleted? But if you have everything in a file, all you need to do is you come and read that file. And then so you use only that file in deploying services in your account. And if you don't need those services, you can go ahead and readjust and maybe edit your code and then deploy it, and then maybe the files, the services that you don't longer need, they'll be deleted. So so it's a very good, CloudFormation is a big topic on its own. It's a skill that is necessary to have if you are planning to work as a cloud engineer and of course architect, but as a cloud engineer or infrastructure engineer, you need skills on CloudFormation, and it's not very complex writing this. It's always something that when you start, you getting used to bit by bit. So make sure you have taken note of the key concepts of CloudFormation that I've emphasized on uh, um, infrastructure as code based on templates, and templates are in YAML or JSON format. Elastic Beanstalk is an easy to use service for deploying and scaling web applications and services developed with Java, .NET, Node.js, Python, Ruby. I've just taken this as is listed on the service, and the key thing that we're heading to is just to ensure that you know that this is an example of platform as a service. And if you hear of a question that is talking about deploying web applications, a service that you need, think Elastic Beanstalk. And web applications can be written or can be in these different, developed in these different languages. The one that is closer to Elastic Beanstalk is, not to forget that you only pay for the services you deploy, handles provisioning, load balancing, scaling, and monitoring. The one that I was heading towards, the AWS Light Sail, is almost similar to Elastic Beanstalk, but the key thing here is it comes with pre-configured applications like WordPress, Magneto, Blast, and Joomla. So if you hear a question talking about web applications on AWS Cloud with pre-configured applications like WordPress, then think of AWS Lightsail. So Beanstalk is used for web applications. Lightsail is used for web applications. The difference is that Lightsail comes with some pre-configured applications, or that's WordPress is already pre-configured. If you are going to use Elastic Beanstalk, you have to do all of that. You don't have pre-configured applications on it. So yeah. It's a great tool to use there. Okay, no question. Let's talk about hybrid infrastructure. Should be straight from the notes as well. Hybrid infrastructure, we have talked about hybrid clouds, I should say, where you are trying to connect your on-premises to your VPC. So the first way you can do that is site-to-site VPN, and it enables access to your remote network from your VPC by creating an AWS site-to-site VPN connection and configuring routing to pass through the connection. Connection is automatically encrypted and goes over the public internet. Take note, when you're talking of site-to-site VPN, connection is encrypted and it goes over the public internet or goes through the public internet. Yes, that's notice that's used interchangeable. And these are the key things you have. On the AWS network, you always need a virtual private gateway. On the on-premises network, you always need a customer gateway. And then you'll be able to build a VPN connection. If you're still doubting, if this is still a problem, there's a link here to visit and check on that. So that's one way of doing connecting your on-premises to the cloud. The second one is hybrid infrastructure, direct connect. With direct connect, notice that it's a dedicated network connection from your on-premises to VPC, and it allows you to connect your existing on-premises network directly to AWS VPC, which means your data does not go across the public internet. So if you have a question that requires that you connect your on-premises to your VPC, and maybe for some reasons a sensitive workload that is not suitable for public internet, just start looking carefully. Maybe they are trying to see if you understand what direct connect is, because the connection here does not go through the internet and is suitable for highly regulated environments, as I was talking, workloads that have sensitive data. A direct connect fiber connection will connect to an AWS direct connect partner data center. So when you think of direct connect, it's really a cable that runs from one data center to your AWS premises. So telecommunications companies are in charge of installing those cables. So AWS is a global network. So it means AWS connect to some data centers around the world. So if it connects, let's say, to a data center that is sitting somewhere here in Düsseldorf close to me, and let's say there was a Wilfon Cloud premises sitting here in Düsseldorf, and I want to have a direct connection. So a telecommunications company will actually go to the data center where I have my end connection and run a cable from there right to my own premises. So that's how, when you think of direct connect, think of a real physical cable running from one end to the other. So we'll connect that to AWS network, but that is the details of how that is done is more when you go to the higher levels. But just know that the key thing here is a dedicated connection. It does not go across the internet. It's for workloads that have sensitive data. Those are the key things. Connecting VPCs. There are two ways of doing so. You have VPC pairing. This is just for connecting when you want to connect only two VPCs. But and then it's not transitive. We did discuss what that means in our notes. If you are missing that, try to check that again. But the key component here is it connects two VPCs. The transit gateway is used for connecting multiple VCs and on-premises. So why do, with the VPC pairing, as I always say, when you're reading these technologies, always try to ask, why did they create the transit gateway? The VPC could connect just two VPCs, but imagine a customer that had 5, 10 VPCs. What is he going to do? So the transit gateway came into existence to connect multiple VPCs, and the good thing is that it also connect on premises. So it added an additional functionality. I think there's a good diagram that we looked into, and it's transitive in nature. So I think I had to delete that. Sorry. So that is that on transitive gateway. Now, Route 53 is a highly available and scalable cloud domain name system for web service. So when you think of Route 53, think of DNS. Route 53 is a DNS service, domain name system. So it helps in the translation of names like Amazon, AWS Amazon.com to numeric IP addresses that computers understand. We did talk about the DNS service is used, computers communicate using IP addresses. And the only reason if we want to access aws.amazon.com, every website that you know of has an IP address behind it. Because the reason why the DNS functionality had to be introduced was because it's just impractical to be remembering websites by their IP addresses. I don't think anyone will be able to remember two, yeah, how many addresses. I mean, even if you're as good as what, maybe by the time you are reaching 5 or 10, you won't make it. So, but we can remember addresses if we just see familiar names, because that's what is easy for us. So the DNS service came in to be able to translate, to have IP address for the names that you give. Let's say if you take an IP address and you give it a certain name, then DNS will translate it and make it easy for computers to read, and for us humans, we'll be able to read the names that we have. So it operates at the edge locations and it's a global service. And these are some of the things that, interestingly, you may not be aware, but remember that with Route 53, you can register your domain names. You can create different DNS routing configurations. There was a question on that, and it performs health checks on your services. So make sure that you keep in mind these three key areas of what you can do with Route 53, apart from it being a domain name service. Then Amazon EFS, what's that? It's a fully managed elastic NFS file system for use with cloud, AWS cloud. It's built to scale on demand to petabytes without disrupting applications. When you think of EFS, think of when you want to connect more than, well, you want a storage system that um, um, instances, and here in this case, Linux instances can connect to more than one, at the same time. We did say that by default, EBS volumes, you can only use that on one instance, but EFS can connect, you can connect many instances on it if you want, and so they can access the same storage space and read and write on it. And it's designed for Linux systems, take note of that. It stores data across multiple AZs, and it comes in different storage classes. The key thing for the practitioner here is recognize that this is used when you want more than one instances to access the same workload, and that is stored across multiple AZs, and that it provides, yeah, those are the key things. It stores in different data centers. And then you have the one that supports Windows, Linux, and Mac OS is what is referred to as the Amazon FSX for Windows File Server. Take good note for this one. If you come across a question and they're talking of, you have an EC2 instance that supports an EC2 instance that is having a Windows operating system, and you need them to access the same storage space, this is the one you should think of. I mean, we've talked about Windows and Linux, but take note that if you also have a Mac operating system, and if it has to access, and many of them have to access the same file system, it is the Amazon FSX for Windows file server that a Mac operating system will use. I'm saying so, it's easy to remember Windows and Linux, but then remember that Mac OS is also another operating system, and it falls under the FSX Windows file system. So make sure you pick those. The service that is of interest here again is Lambda. We've mentioned this a couple of times. It's a serverless service. It falls under compute, and it lets you run code without provision or managing any servers. You pay only for the compute time you consume, and you only charge for users based on execution time. So if you have code and it runs for 1 minute, that's the only thing you pay for. If the code runs for 10 minutes, that's the only time you pay for. So it's a very, um, it's a serverless, it's very, it's a primary service for serverless architecture. It enables event-driven workflows. Remember, Lambda is for event-driven workflows. It integrates with many services, and the maximum execution time is 15 minutes. I just added that just in case, but just keep in mind that the maximum time that a Lambda function will run is 15 minutes. And it is used for microservice architecture. The other services that fall in line here is the Amazon Simple Queue service. And this one is a fully managed messaging queue service that enables you to decouple and scale microservices, distributed system, and serverless applications. In most of the revisions we've had, is always trying to see if you understand that the SQS is used to decouple and scale microservices, and the fact that it's also a messaging queuing service. So make sure that you have that definition. um, yeah, you have a good understanding of that. And it's also used to build, decouple, and fault tolerant applications. It support up to 256 KB data payload, allow message to be stored up to 14 days. Just some extra details. And there are two types of queues when you are running the simple queue service: the standard and the FIFO queue, first in, first out. What's really key here for the practitioner is what we have on this first page. But this is just a good to know in case you want to be completely set. Then we also have the SNS service, which is a highly available, durable, secure, fully managed, what is referred to POP-SOP messaging service that enables you to decouple microservices as well, and distributed systems and serverless applications. Um, Um, it's also integrates with multiple AWS services, and it provides end user notifications. That's what is very key. That makes it different from SQS. Uh, it provides end user notifications across SMS, email, and other push notification endpoint. So when you are thinking of, if you see a service and they are talking of end user notifications across SMS, email, and other push notifications, it's very likely that it may be Amazon Simple Notification Service. Just make sure you cover that service very well. These are two important services that I think everyone should make sure they have a good grasp of them. You can't go to the exam without knowing what Amazon CloudFront is. It's part of the content delivery network of Amazon, and its main issue is to reduce the latency for content delivery. So you find it mostly in edge applications, edge locations, sorry, yeah, edge locations. So where end users live. So when you think of CloudFront, think of caching, think of reduction in latency, and it also helps to improve security because it works with AWS Shield, AWS WAF, and can actually reduce cost for you. So um, the key things about CloudFront here, make sure that you have them. Okay, AWS X-Ray, analyze and debug production distributed applications, and yeah, helps developers analyze, debug production distributors such as those built with microservices. That's just the definition. There's not really much we can talk about here. We have seen that a couple of times in our discussions. I brought CloudTrail here for completeness sake. Um, it's a very important service, I would say, for the practitioner exam. Make sure you really understand the service well, where what it's doing, the different areas that it functions in, and the questions that we've been drilling ourselves with CloudTrail is good. It's just they're very essential. to help you make sure you have a good understanding. It enables governance, compliance, operational auditing, and risk auditing of your AWS account. Always remember that CloudTrail is always going to refer to your AWS account. You can log and continuously monitor and retain account activity related to actions across your AWS infrastructure. CloudTrail provides event history of your AWS account activity, including actions taken through the AWS Management Console, SDKs, and command line tools. So remember that we gave three ways you can access AWS or you can interact with AWS services. We had the console, we had the command line, and we had SDK. So CloudTrail is able to track whatever all the events or that are happening or whatever that is coming through these tools. It's where CloudTrail is able um, to actually look at the event history and take actions. Okay, that was very long for three. I will want to stop here.